Okay, so let's have a look at this problem 2392, which is a build a matrix with conditions. And let's check the example first. So the input would be three things. First is integer, which is k. That means finally you are gonna to output a matrix with size of k. And another two parameters is row conditions and column conditions. And that means, for example, this 1 and 2, that means in any row here, 1 should exist before than 2. And 3, 2 means 3 should exist before 2. And the same thing for column conditions. So yeah, that's a constraint. So based on that, we are supposed to output a matrix with a proper value from 1 to k. I think this one is very straightforward actually, because the constraint is just we can treat the constraint here as a directed edge. So that means it likes a pre-request before 2. There should be 1. Right? Is that something familiar? So let's have a look at the topological sort. So what a topological sort can do? So it can give you a topological sort based on the directed graph that satisfy all the prerequests exist before than the second condition, right? So for example, if I'm given some directed edge like 1 to 2, then after that 2 to 3. So these are two directed edges, and then you want to build an order, and within this order, each of the continuous 2 number follows the rules here. So we can use a topological sort to do that, right? Topological sort. So if you get this, then the overall solution would be very straightforward. So what I'm gonna to do is to treat the row conditions as directed edge or directed graph. Then I want to find the valid directed topological sort. After that, I will get the correct order of the numbers here, and then I can reconstruct the row distribution or allocation of the numbers. And if I did the same thing for the column as well, then I will get another topological sort which satisfies the conditions here. So after doing that, I will get the correct location for each number both on row and column. Then I can reconstruct the matrix. And for the arrow handling part, if any of the requirement is not possible to satisfy, then I will just output an empty matrix, which is also the requirement of the problem description. So yeah, so let's do that. Let's try the topological sort first. So my habit to do that is use a color array, and so the nodes here should start from 1 to k. So the overall size would be k plus 1. So like initialize with this, and then this T array will store the correct topological sort. So let's do that. So for the DFS, so the input would be a node, and then first thing is set this node to 1, which means visiting, and then iterate all the following neighbors of the node. Then do a check for this node. First, the check would be if the state of the node is being visited. So that means the value is equals to 1. Then we can just simply return false. That means we have some circular dependent, right? 1 dependent to 2 and 2 dependent to 1. Then it will give our acyclic directed graph, which is not good. So else, another thing we want to check is so if the neighbor is already visited and we already put them into a corrected topological sort or topological order, then we can just skip it, right? Skip it. After that, continue. So the else would be the color of the neighbor equals to 0, which is not visited yet. So if that's the case, then we will try to visit that. So let's visit that. So if any of the child or neighbors is not valid, then we can also return the false. So if not 10, then we can return false. So after that, it passed all the check. That means this looks good. This node looks good. Then we can first we want to switch the node status to from visiting to visited, which is 2. Then put this node to the topological sort order. Then return true. That means yes, we can find the valid order that satisfy all the conditions. After that, we will have a correct order T here. So if it's false, then we can just return an empty matrix. So the other thing is we want to use, we want to build different graphs here, right? So for the row, we will have, for the row and columns, we will have different graphs. So let's use this. I'm using the default value of this graph as a set because sometimes there might be some duplicated edge. For example, the row conditions is 1, 2 and 1, 2. Then by doing this way, we will only record a single unique 2 here. Okay, so let's build the graph. And another thing, we also want to find the degree of the node, right? So if the node, I mean in degree. So if that will help us to find which should be the entry point of the topological sort. So we will only start from the high priority node, which also in another word, that means the in degree of that node should be 0. Then we can start from that node. So let's do a counter to record the in degree of each node. So for concise representation, let me change this variable name. After that, so we got the x and y. Then we want to put, for example, we want to put 1 as the prerequisite of 2. So which is y, and add x. And after that, the in degree of 1 should increase. In degree of x should increase. And after that, we got a good in degree map or counter. And then we also have a map here. So let's do the topological sort. So from 1 to k plus 1. Then we need to check 2 things. First, if the in degree of this node equals to 0 or not. So if it equals to 0, then we want to check if the visiting status of that node is 0 or not, right? So, and then we can do a topological sort, and then we verify the status or the results of this topological sort. So if not TMP, that means we cannot find a valid order that satisfy all the conditions. So we can just return an empty array, empty matrix. Yeah, so after that, yeah, so, and there's a corner case here. So for example, if it has a cyclic, if it's a cyclic directed graph, then no node will be no node can pass into this DFS function, right? That means it's also not good. So we want to record that as well. So we use a flag to check if some of the node is in degree is 0. So once that is satisfied, then we can change this flag to true. And if not flag, that means nobody, no node has 0 in degree. That means we have a circle or cyclic dependency in this directed graph. So if that's the case, we can just return an empty matrix. After that, we can record the topological order. So let's do the same thing for the row conditions as well. All the things are exactly same. So we reset the color and the order and the graph and the counter, but the way we build the graph has changed, but the mechanism is not changed. And flag and do the same thing, but we want to assign the order to another array. So after we getting all of the row conditions and column conditions and the correct order, then we want to represent this order in the output matrix, right? So we first let's identify the output matrix. What should this matrix look like? First, the size of it should be k plus k, right? So let's initialize that way. So after doing that, we also need to map to record all the values location in row and column. So that can be done within this enumeration. So we do the enumeration of first order, then that means the column, the value should be put in index here, and another enumeration, the column order, and the value should put in this location, and then we put the number one by one, right? So start from 1 to k, and then put the correct location. First is the row location, then the column location, then equals to this number, and return the results. Okay, I think that's it. So first, let's check one by one. First, let's check the depth search to do the topological sort. So first, we put them into, we check out the neighbors status. 1 return false and 2 continue. Only 0 can go to next recursion. And we also check the output for next recursion. If it's false, then we can return false. Then put the numbers here, then record the nodes, then return true. This looks good. Then the initialization parts, color, k plus 1, that's correct. And this number, yeah, it looks good. So let's check some of the examples. right? So it looks good. So 1 and 3 can be alternative switch. And the second example should return an empty array. Yeah, it looks good. So let's verify by submitting it. Yeah, it satisfies all the testing case, right? So let's do this in Java as well. This is the first time I write Java code about the topological sort. So let's do this. So hash map and yeah, I would say the input should be an integer and the value should be a hash set of integer. And we want to row graph and the column graph as well. Column graph. And after that we want to know we also want to know the list of integer of the two correct order T0 and T1. Then the color array, right? Color array, so which is the color array should the size is already known, so let's initialize this way. Then that's it, right? That should be the yes. That's it. Now let's build the most essential function here. The should return Boolean value, DFS, and then the input should be an integer, and the row direction or the column direction. So if that's the case, then yeah. So let's separate them together. Separate them totally. So for color, I'm using 0 for row and 1 for column. So if that's the case, then if index equals to 0, then color 0, node assign 1, then iterate all the integer here of there's some scenario that there's no constriction totally, so let's separate the logic totally here, right? So color this, then if gr should contains this node, contains key node, so else or after processing all the neighbors of node, after that we can allocate or assign the values of node to 2 and return true. So if we not return false here, then we should return true, and put the nodes to T0. Okay, then we can iterate all the neighbors of get node. Okay, then we check the stutters, color 0, if it equals to if it equals to 0, or let's verify this first, then return false, else if this color 0 then we can just continue, and else we return a boolean value results here, dfs, then the neighbors and the index here, and if not results, we can just return false. Okay, after that, all good. So the same thing for another scenario of column, but we need to substitute the variables here. So it should be GSA and node and color1, then they should not be changed, and color1 T1. Okay, so this function is finished. You can just return false here. Okay, then we should initialize them, right? So it equals to hash map and GC equals to hash map and T0 equals to the array list of integer. And the color 0 should equals to the length of k plus 1, and color 1 should also equals to this. Okay, after initializing them, let's build them. So for int I equals to 0, yeah, let's do the same thing here. rc.length I plus so if tr not contains, so we want to put y to x, right? So contains key rci1, then gr dot put rc1 with new hash set of integer, and then gr dot get rci1 dot add rci0. Yeah, we also want a counter which is in degree k plus 1 and d1 equals to k plus 1, and right over here we want to increase the rci0. Okay, after that let's do the same thing for the column conditions as well. So this should be GC and CC and GC, CC here, D1, CC. Okay, after doing that, we got the graph and the integrate. So let's verify them one by one. So first, for int I equals to 1, I smaller or equals to k, and then verify two things. First, yeah, we also want a boolean flag equals to false first. Then if d0 I equals to 0, then set this flag to true. Then we also want to verify the color 0 of the I, if it equals to 0 as well. Then we verify the results here. Right, so for node I and the index is 0. So if not tmp, then we just return the empty array. So the empty array and after that, then we got T0. Yeah, so we also want another array, which is the, let me do this. So we save all the values, where there should be the rm. And after that, we also want the cm here. Then we do the iterations. 0 I so the value of the cm, the color, yeah, I think I should start with 0 to, oh no, yeah, 1 to the k, right? Cm T0 I equals to what? Yeah, this should be, sorry, this should be 0 and k. Then this should be I. Yeah, let me try another thing as well. Yeah, so, yeah, okay. So let's do this. And if not f1, then return results. After that, we got the, oh, this should be rm. Then exactly same thing here for the column condition, but the only thing changed is the index and f2 and color 1, index 1 and f2, and this should be cm, and this is t1. Then we initialize the final results, k plus k here. Then do the allocations, I equals to 1 and I smaller or equal to k, I plus plus. Then we find the correct locations, so rm I and the cm I equals to I. And return the answers here. Yeah, it should pass. Let me try first. Okay. Oh, okay. There should be integer. Yep, this should be. D0, yeah, also this, T01, line 42, Color 0. Yeah, so let me output the values here. System dot out dot println. Alright, let's check what's the values for this. Color 0 I. Okay, yeah, so let me just explicitly initialize this. It will not complain about that. Okay, already found that. Okay. RM. Okay, so this should be like this, right? And that's the reason why it's complaining about. T0, T0, then T0 add what? Add a node. Oh, okay, I see. So it should be something like this, right? This is should be get, right? I think that's an issue, so let me change that part. This T1 and the CM. Line 100. Okay. Try to do this. Okay, RM is out of range. That means some of the failure is not catched. Okay, so let me check. T0 add node. I. So T0 contains, so RM should be initialized with this one. Should be good. Let me verify the first case. Alright, so I is equals to T0, the first value, index out of bound. So let me system dot output println with the value of the T0 dot size, right? Plus this size. I can verify that. Okay, so I'm trying to get this with 1. So T0 only got 1, but it actually should be some other values. Okay, so initialize value of D1 and D0. Oh, I see here. No, that's not the reason. So I is a should be fine, but why RM only so let me try this. Plus RM dot plan. Right, so it should be something. Oh, I see. So that the reason is T0 is too short. It should contain fully values here. Okay, so let me output the I'm suspect with the color value here. So I plus column plus the color I 0 I show the value should be there. Is this 0? Okay, 2 is not 0. And plus the indigo value as well. Two should be the starting point, but while doing the DFS of 2, I'm only add one number, code 0. Oh, I see. This should be contains key. That's the reason. Okay. So after that, we got the correct values. We comment out the comments. Let's try some other scenarios. Okay, and the another output here. And submit. Okay, it passed. Oh, but with many memory. I think I can simplify some of the logic. Like put the hash map array here as a G. Yep, so that's it. That's the solution of Java. So let me avoid the C++ this video because it takes too much longer time. So that's it. This is the first time I try to record with English.